Hello all. As we know that this is a lecture series for 12th chemistry NCERT, and you know that this is the lecture number 8 with the unit number 10. Okay, lecture number 8, unit number 10, haloalkanes and haloarenes, and this is based on 12th chemistry NCERT book. As you know, today's topic is chemical reactions, nucleophilic substitutions, elimination reactions, and reaction with metal. These three will try to cover it. So let's see how many we can cover it, and this is free of cost, and this lecture series, entire lecture series for 12th chemistry NCERT, I'll provide you at free of cost. Correct? You will, what you are going to get it through this free lecture, you will get full concepts, you will get notes also. Okay, so no need to depend on any coaching institute. Directly you will get it through this YouTube channel. So this is Dr. Gopinath Gorai, Assistant Professor, St. Xavier's College, Maharo, Dumka. So let us start with the lecture. So first with the chemical reactions. And for the previous lectures, you watch it in this playlist. You will find all the from lecture 1 to lecture 7. You will get nice concepts for all the topic which I have covered here. So without delaying, let us start the chemical reactions. So this is your chemical reactions. Okay, so to start with, just write it down. The reaction, okay, the reactions of haloalkanes may be, okay, may be divided into the following categories. Okay, categories, and the categories we have already discussed in our first slide. That is, first we will discuss with nucleophilic substitution. Okay, nucleophilic substitutions. Second, we will discuss elimination reaction, and then third, we will discuss reaction with metal, reaction with metal. Okay, so let us discuss one by one. First, we will take the nucleophilic substitution. Okay, nucleophilic substitution. Okay, first we will discuss with nucleophilic substitution. So first write it down, then we will discuss it, and it is going to be a nice class. So a nucleophile, okay, a nucleophile. So as we move, we'll just discuss what is nucleophile. See, nucleophile means the species which have the electron density. Okay, electron density. It can be it can be neutral or it can be negatively charged. Neutral means suppose you have NH3. Okay, NH3. Neutrophil means PCl3. These are all the neutral nucleophile. Now the charged nucleophile, we are going to discuss for charged nucleophile Cl minus, OH minus. Okay, there are many which are the charged nucleophiles. See, in this nucleophile we have this electron density. Correct. So nucleophiles, again, if we want to break this nucleophile, what you are going to get? Nucleophile, just break it. Nucleophile, phile means attracting, loving. Okay, we can write loving or tendency, like the towards the tendency or attracting, we can say. Okay, so loving, and nucleo means positive, so positive loving. So who will have this positive loving? The negative charge. So that's why nucleophile is the electron density. Okay, the species which have more electron density, and it can donate this electron density, right? So that is the nucleophile. So again, to continue with the notes, we'll write a nucleophile react with this, whatever I'm explaining in blue color, that you take down to your margin page. Okay, so a nucleophile reacts with haloalkanes. Okay, haloalkanes having a partial positive charge on the carbon atom bonded to halogen. Okay, a nucleophile react with haloalkanes having a partial positive charge. See, it should have partial positive charge where it will go and react. Okay, nucleophile where it will go and react, where the partial positive charge will present on the carbon atom. Correct. It means the nucleophile itself is having negative charge, so it will go and attack towards the partial positive charge. Okay, and if bond is between carbon and halogen, we already know that carbon is belonging to group 14, halogen is belonging to group 17. Now if you see, the electronegativity differences is more, but the more electronegative element is your halogen. So what will happen, both the bonded pair of electron will move towards halogen side. Okay, then it will be having partial negative and carbon will have partial positive charge. Okay, so we can write a substitution reaction. Substitution reaction takes place. Okay, takes place, and halogen atom called leaving group, okay, departs as halide ion. Correct. So the halogen will leave as an halide ion, so that will be leaving group. Okay, so see, we know that substitution. What does mean of substitution? It will like one group is added and another group will be leaving. It will be simultaneously. Okay, so that we have to see whether both the group are together present in a molecule. If it is so, then it will be SN2. If suppose first leaving group is going from the molecule and then reactive intermediate is forming, then your the nucleophile is attacking, then it will be SN1. Okay, we'll discuss what is SN1, SN2. Okay, so now we can write it, since the substitution reaction is initiated by a nucleophile. Okay, it is called nucleophilic substitution reaction. Okay, nucleophilic substitution reaction. Correct. How? Suppose this is nucleophile. This nucleophile will attack to your carbon and here halogen. So we know that here it will be partial negative, here it will be partial positive. So this is nucleophile. It will attack over here because positivity is over here. It won't attack over here to this halogen because here the negativity will be more and this negative repulsion will be there. So that's why it will attack over here. Okay. Then in the next step, what will happen? This nucleophile will be directly attached to this carbon atom. Okay. And your halide will go away. Okay. We can say that it will go out. Correct. So this type of reaction we will see over here for the nucleophilic substitution reaction. So how mechanism will work? The two types of mechanism it will work. So first we will see, that is SN2. Okay, what is SN2? It will be nucleophilic substitution. Nucleophilic substitution. Okay, see here, 2 means bimolecular, 1 means unimolecular. Bimolecular. Correct. So that is SN2. So nucleophilic substitution bimolecular. So in this, what will happen? The incoming group and the leaving group both will be present together. So we will call it. It is a bimolecule, and the rate of reaction will depend for both the substrate. Okay. So let's see. Suppose we are taking, this is your nucleophile OH minus. This is the compound we have. This is the carbon. One hydrogen is over here. Another hydrogen suppose here, and this is the third hydrogen. Now it is attached with this halide. So what is happening? So we can't See, this is not intermediate, which I am going to draw now. That is not intermediate, so it will attack over here. So, and then, so I am just drawing the dotted line. Okay, this is not solid bond. So here one hydrogen, then this is your hydrogen, and here one more hydrogen, and this also I will draw the dotted line. Okay, chlorine. So now you just see this we call transition state. See, transition state is something different than your reactive intermediate. See, reactive intermediate we can isolate it, but transition state we can't isolate, correct? So transition state we can't isolate it. It's only we can see that, okay, this is the way the reaction is happening, correct? So it's just an explanation. But reactive intermediate we can isolate it for a fraction of second also, but this is we can't isolate to show it, because see, carbon never have 5 valency. But here, if you are counting 1, 2, 3, 4, 5, right? To only showing purpose that this substrate, okay, the nucleophile, it is attacking to the carbon, and the same time this chlorine is leaving from this molecule. So it is like both the substrate, the incoming substrate and the leaving substrate, both the substrate is like anyway it is connected to the carbon, okay, so we call it, it's a bimolecular, okay, nucleophilic substitution bimolecular, we call it bimolecular, correct? Now in the next step what will happen, as you know, this is the stable, so here it will be hydrogen, then your hydrogen and the hydrogen, okay, and then the halide will go out. So this is SN2. So have you noticed one thing, in SN2 we don't have any intermediate, we don't have any reactive intermediate, okay, it won't form reactive intermediate. It means there is no carbocation carbanion, correct? So we can't form it, we can't isolate the carbocation carbanion. And which type of molecule it will follow the SN2? The molecule which is having more spacious, see this is hydrogen, it will occupy this much space, the peripheral space I am talking about. This hydrogen will also occupy this much space, this hydrogen is also occupying only this much space. Now you have empty of spaces, see, from here to here you have spaces, so the OH minus can attack to this carbon, okay, through this in between molecule, in between hydrogen, it can attack because there is plenty of space to attacking, correct? So that's why SN2 is taking place on primary and somehow in secondary, but it won't take place in tertiary. Okay, it won't take place on tertiary, but primary it will be very much, it will be taking by the SN2. Okay, in secondary maybe 50 to 60% chances are there, in secondary it will take place, but tertiary it won't takes place, correct? So we'll write few lines and then we'll discuss why it is not taking place in a tertiary, correct? So first we'll write it, so just write it down, the reaction, okay, the reaction between CH3Cl and hydroxide ion, it is getting from your NaOH or KOH aqueous to yield methanol and chloride ion, correct? Follows a second order, okay, how it is following second order, I'll discuss you kinetic, second order kinetics, that is the rate depends upon the concentration, okay, of both the reactants, okay, the concentration depends upon both the reactants. How it is depending on both the reactants? See, OH is attacking, Cl is going away, so it is depending on both the reactant, okay, that's why it is second order kinetics. If suppose it is depend only on this alkyl halide, then we call it first order reaction. If it is only depending on this aqueous KOH, then it is first order reaction. But if it is depending on concentration of your OH minus as well as for your alkyl halide, then we call it is depending on both of these substrate. Okay, so if it is depending on both of these substrates, so we call it second order kinetics. Okay, more you will get to know in the topic in the chapter name chemical kinetics, correct? So now we in this reaction what we will get it. Okay, after this, we'll just put these reactions over here, whatever we have discussed previously, that you put it over here, and then we can write here we get, okay, here we get the inversion, okay, inversion. What is the inversion? Inversion of configuration. We are getting inversion of configuration. Correct. If you are starting with R, your product will be S. Why? Because it is attacking from back side. Okay. If it is, see, the chlorine is this side. The OH is attacking from back side. If it is attacking from back side, then everything will get changed, right? If you are like suppose this should be not hydrogen. It should be like here it should be CS3. Maybe here some other group. Here some other functional group. And then if you are attacking, then what you will get it that here you will find the inversion of configuration. If you are starting with S, you will get R. If you are starting with R, you will get S of your product. Correct? So that is only here we get the inversion of configuration. Correct? And what is the order of reactivity? So I'm talking about SN2. Okay, for SN2, what is the order of reactivity? See, order of reactivity. See, whatever we are going to discuss it over here for order of reactivity, that will be reverse for your SN2 because this is we are discussing for SN1. So we know that, just first we'll write it down. Okay, then we'll discuss. So it is methyl, okay, halide, methyl halide react most rapidly in SN2, okay, reactions because these are only three small, as I told you, small hydrogen atoms. Okay, but what about tertiary? See, tertiary halide are the least reactive. Okay, least reactive. Why? Because bulky. Okay, bulky. Okay, bulky means steric hindrance will play a role over here. Bulky groups. See, methyls are bulky groups. Okay, bulky groups hinder. Okay, hinder means will not allow to go till the carbon center. Okay, hinder the approaching. Okay, hinder the approaching nucleophiles. Correct. Thus the order. What will be the order? What could be the order? It will be your primary halide will have more towards SN2 than your secondary halide and the least your tertiary halide. Got it? So your least will be your tertiary halide. And why so? So we'll draw all the three over here and we'll see how the nucleophile is attacking over here. So this is your carbon center here halide. You have one hydrogen. You have another hydrogen over here. You have one more hydrogen over here. Now this nucleophile. Okay, if this nucleophile want to attack over here, you see there is a plenty of space, so it can attack, right? So and we know that this carbon is not attaching with any of the carbon, so this is either 0 degree or primary, you can say it, right? Then now next, what is happening? So we call it 0 degree because it is not connected with any of the carbon. So now second will be your, suppose this is the carbon which is connected to your halide. Now this is directly connected to your methyl group CH3. Now one side it is hydrogen, another side it is hydrogen, and I'll open and write this CH3. If I'm writing like this, you will see that space is there, but why I'm not saying that space is not there? So now you see, here the space is this much, but here the space is less. So the nucleophile will attack over here through this, correct? So space is little bit less. So this is primary. And if we are talking about secondary, here it is carbon, hydrogen, hydrogen, hydrogen. Then here one more carbon, hydrogen, 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 and here one hydrogen. So now you see, for this nucleophile, you are getting only this much, okay, to react. So this is secondary. Now regarding this carbon, okay, this is halide. One carbon is there, hydrogen, hydrogen. Another carbon is there, hydrogen, hydrogen, hydrogen. One more carbon is there, hydrogen, hydrogen, hydrogen. See how much crowding this place, okay, the crowded place. So nucleophile can't enter, not from this side, not from this side, okay, it can't enter any of the side. So this is tertiary. It is a similar way. Suppose you have a bus, you are standing in a bus stop, okay, if you are standing in a bus stop, there's two gate, one is this front side, another one is in back side, correct? Now in the condition 1, both the side it is empty, no one is standing on the gate, so you can enter from both the way, either through this side or this side, okay, you can enter it. Now suppose what happened, second condition, here few people are standing, okay, and now you are standing over here. So bus came, which side you will, and this side no one is standing, so what you will do it, whether you will go this side or you will go this side, you will prefer to go this side, right? You are not going to this side because nobody likes this steric hindrance or the population where the standing on the gate, excuse me. So you will prefer to go this way, correct? And suppose the third condition, if suppose this side also people is standing, then what will see? You will look for the next bus, correct? You will looking for the next bus. You are not going to board to this bus, correct? Why? Because it is too much crowded. So that thing happening for your chemistry also, right? It's a 0 degree, it is 1 degree, it's a 2 degree, 3 degree. Now you only decide the for SN2, the nucleophile has to attack to the carbon center. As soon as it will attack, the immediately this halide will go away from here. So that's the case what we have discussed over here, correct? Got it? So this is the mechanism. That's why we have primary halide will have more tending towards SN2, then secondary, then tertiary, correct? Got it? Excuse me. Then second is your SN1. Okay, SN1. So what is SN1? It is your nucleophilic, okay, nucleophilic substitution, okay, nucleophilic substitution, unimolecular, okay, unimolecular. See, unimolecular, only one molecule will be or one substrate will be at a time. So now by seeing SN1 only we can conclude it. So it will be your first order kinetics. Okay, what will be the kinetics? Order of kinetics. So it will be first order because at a time only one substrate will be there, or it is depending. The reaction is directly depending on a alkyl halide, not your hydroxide. Okay. So what is the the concentration of alkyl halide? If it is more, then this will be moving forward direction very fast. If your alkyl halide concentration is less, then the reaction will be slowing down, correct? So first we will write it down and then we will discuss it. So here reactions, SN1 reactions are generally carried carried out in polar, okay, polar protic solvent. Okay, so to identify whether it's SN1 or SN2, one is like if it is tertiary, it will be definitely SN1. Second thing, you have to identify the solvent. If in the arrowhead, suppose this is an arrowhead, okay, I'll just write it down. If this is an arrowhead and here if it is writing solvent name something polar, okay, if they are writing polar solvent, okay, polar solvent, then you have to identify, okay, our reaction is going through SN1, okay, polar solvent. And if it is SN2, you will find the non-polar solvent, okay, solvent will be non-polar for SN2. And for SN1, they will use polar solvent. So these are the indicator to indicate whether this is your SN1 or SN2, okay. In your competition examination, if they are asking whether it will follow SN1 or SN2, you have to look whether it's a tertiary or primary. After that, you have to look whether it's polar solvent or non-polar solvent, correct? So it's a polar protic solvent, okay. The reaction, okay, we'll continue. The reaction between tertiary, okay, butyl bromide, okay, and hydroxide ion yield tertiary butyl alcohol, okay, tertiary butyl alcohol, and followed the first order kinetics. What is that? That is the rate of reaction depends upon the concentration of only one reactant, okay, only one reactant, which is tertiary butyl bromide. What it's like you have this CS3, CS3, CS3. Why this one is tertiary? Because the carbon attached to the halogen, that particular carbon is attached with 3 alpha carbon. Okay, this is alpha, this is alpha, this is alpha. So 3 alpha, so it is tertiary. Now, if you are reacting with OH minus, what you are going to get it? It will be CS3, then you are getting CS3, CS3, and OH you will get it, correct? And your alkyl and your bromide will be go away. So it will follow two-step mechanism. In SN2, only one step we have completed, but here there will be two-step mechanism, and here you will come to know the reactive intermediate. Okay, it is forming the reactive intermediate. So mechanism part we will see it how it is following. So it occurs in two step. Okay, so there will be two step. So first step, or we can say that step one, it will be your tertiary butyl bromide. Okay, it will just dissociate it. We have polar solvent. Okay, so what will happen? It will just break this bond, and here it will be positive, and whatever the Br minus is there, the solvation will take place. The polar solvent, no, polar solvent. Due to this polar solvent, this bromide will be what we can say, it will be like solvated to this polar solvent, correct? Now this part, the carbocation we have, this is tertiary carbocation. So this is a reactive intermediate, right? Tertiary carbocation, and it is very much stable. We know that we can stabilize it through inductive effect. 3 plus I effect is there, so it is more stable, or we can expand the stability through hyperconjugation. So here 3 alpha hydrogen, 3 alpha hydrogen, 3 alpha hydrogen, total 9 alpha hydrogen. So the total 9 hyperconjugating structure you can make it. So it is highly stable. So by whether you want to uh, like what is you want to explain the stability, or you justify your stability through inductive effect, you can do this, or if you want through hyperconjugation, that also you can do it, correct? So this is the first step. Okay, now in the next step what will happen? See, CS3, we have this CS3, and now this CS3, and here it is positive charge. Now you just tell me, this is your sp3 hybridization, right? Sp3 hybridization, so it is tetrahedral, correct? And it is not planar. Now in this case, this carbocation is sp2, correct? This carbocation is sp2, and if it is sp2, it means it is a planar molecule. If it is planar molecule, it means, see, your page or your notebook or your mobile phone, it's a planar, right? So if something is planar, you have two faces. One will be your upper side face and another will be your lower side face. Suppose this is from top side, this face is, okay, means your page is, this is your page. In this page, this is the top face, and this side, from this side it is bottom face, correct? This is your top face and this is your bottom face. Now your hydroxide is having two way of attacking to this carbon, because as it is planar, so what it will do, it will now not go in between these two methyl or these two methyl or these two methyl. What it will do, it will go from either top side or it will go from bottom side. So if it is going through top side, so OH will be on top and this CH3 will be below. If it is going from downside, OH will be at the down and this CH3 will be on top. So what you are going to get it. So suppose if I am attacking from top side, your OH will be over here, your one CH3 will be here, another CH3 will be here, and one more CH3 will be on the back side. Now it is sp3, and we know that it is tetrahedral. It is not planar now. So this is sp3. You are getting sp3. Now you just see, if suppose you have started with R configuration, suppose if this three, because we know that R and S configuration only we can give if the functional group are different. Suppose in this carbon, one is bromine, one is chlorine, one is OH and one is CH3. All the different functional group attached to the carbon, then only we can give R and S. Now, for time being, you just suppose it is, if you started with R, so what could be the product? Whether it could be S or it will be R. See, here it will be R plus S both. Okay. Why? We will get racemic mixture. So are you getting in SN2 what you are getting? In SN2 you are getting inversion of product. If you are starting with R, you will get S. If you are starting with S, you will get R. But in this case, you are getting the product which is a racemic mixture. Means you are starting with the enantiometric pure compound. This is enantiometric pure compound. See, whether R or S, it will be enantiometric pure compound. If you are starting with one of the compound and which product you are going to get it, you will get racemic mixture. Correct? You are not getting an enantiomeric pure compound. Why? Because now it is a planar molecule. So planar molecule, the OH minus can attack from top as well as from bottom also. If it is attacking from top, this will be your molecular structure. If you are attacking from bottom, then another type of molecule can be possible. Suppose if it is attacking from top, you are getting this. If you are attacking from bottom, I'll just change the color. This OH minus, if you are attacking from bottom. So what will be your product? Here the carbon. Okay, then here CH3, 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 OH. So these two will have different configuration. So that's why I'm telling you will have it a racemic mixture. Okay, so your product will be a racemic mixture, and for that you have to just do the chiral chromatography to separate it out, these two products. Okay, so now in the next some point you just write it down. I hope it is clear. So just you have to write it down. Since the rate of reaction depends upon the slowest step, the rate of reaction depends only on the concentration of alkyl halide. Okay, alkyl halide. So what could be the order of reaction? I'll just change the color. Your order of reaction will be tertiary will have more towards SN1, then your secondary and then primary. This is having least, correct? So just we will write for the same, okay, for the same reaction or for the same reason. Okay, allylic. Okay, what is allylic? You can see in my previous classes. You will find it in the playlist only. So allylic and benzylic halide Okay, show high reactivity towards SN1 reaction. Okay, though it is primary, secondary, or tertiary, it doesn't depend over there. But if it is allyl or benzylic halide, it will always follow SN1 reaction. Okay, okay. So the carbocation thus formed gets stabilized through resonance. Okay, this is the reason why always it will follow SN1. I'm talking about allylic and benzylic halide. Okay, so see, this is your allylic. Suppose here the carbocation is there. Suppose this is primary only. Okay, this is primary because two hydrogen is there and this carbon is attached with only one alpha carbon. So this one we know that it is primary. So now what is happening? As soon as this carbocation is forming, this will go and attack it. It will form like this. Okay, and then the next structure what you are going to get it, it will be your positive this side. Okay, so this is the stability, and then the next your halide will come and attack over here. Correct. Likewise for benzylic also, this is the benzylic position where your carbocation is present. Okay, this is the benzylic position. Now to neutralize this, the same thing is happening over here. To neutralize this, it will move over here, and then here it will be positive charge. It will move over here. Here it will get positive charge. It will move over here. Positive charge you are getting over here. This bond will shift it over here. Then again positive charge will come over here, right? So this is the, because of resonance, it follow always SN1. Okay, it won't follow SN2. It will always follow SN1. Correct? And what about the reactivity of alkyl halide for both the mechanism? For both the mechanism, if suppose you have alkyl iodide, it will be more reactive towards SN1 or SN2. RBr, RCl, and then RF. So alkyl iodide having the most reactive species either through SN1 or SN2, then your alkyl bromide, then alkyl chloride, then alkyl fluoride. Okay. I think I'm giving you the notes. That's why it is taking much time. Okay. Okay. And that I can't stop it because as I promise it that I will provide you the notes. Okay. I will provide you the notes. The concept I'm providing, no doubt. But as I told you that I will give you notes also, that will be also 100% notes I'm giving. It is not like that I'm hiding something. Okay. I'm giving 100%, and once you complete my classes, like all the lecture if you are completing, you will be able to solve your board examination. Okay, whatever, like in February month you will have board examination. Before that only I'll complete it, all the unit. Okay, organic, inorganic and physical, I'll complete it. Now in the initial it is slowest because see my motivation is that if you're liking these classes, okay, if you are liking these classes, like it and you subscribe it. Okay, if you are doing this, then I'll get motivated and I'll start like lengthier classes, 1 hour, 1.5 hours, 2 hours classes I will make. But now slowly I'm just doing warming up, so at least you also come to know that what I'm providing you, and I also get to know how much interested you are, like how much involved to are you in these classes. Okay, so that's why I'm waiting for your like and subscribe. If I'm getting more, then what I'll do, I will start 1 hour or 2 hours long classes. Okay, so your syllabus will be completed till December only. Otherwise, it will drag it till February. I know, but before your examination, whether I'm doing slow or fast, I'll complete it. But uh, if you want to watch, if you want this full concept at free of cost, if you want all the notes, 100% notes at free of cost, then for that you have to like it and subscribe it, right? Then only I'll come to know that you are watching. So if you are watching, then I'll also give my 100%, correct? So now we have completed today only nucleophilic substitution reaction. So at tomorrow's class I'll complete elimination as well as reaction with metals, or maybe the elimination I'll complete and then I'll go to the reaction with metals, because I'm giving you very descriptive, like concept also I'm giving very descriptive, and notes also I'm giving you very descriptive way. So just after that one revision is required, and that one revision you can attempt your board examination. And I'm sure you will get more than 90% in this chemistry, because chemistry is very easy subject, correct? So all the best. Thank you.